So how did you do it? What was the way? So yeah, I mean, start recording. Let's go. Let's find out how bad this goes.
I think this is going to be quite interesting. Apologies if any of you can't understand our English accents. There's nothing I can do. I can't do an American accent, so I'm not even going to try. There we go. Right, so what I do is I just do the visual cue. So I'll just go 5. Everybody ready, by the way?
Yeah.
Awesome.
Yeah.
Okay. Hello, everybody, and welcome to another E5 podcast. As you can probably tell, this is not the Brady Bunch. This is the largest lineup of guests we've ever had. So before we get on, let me introduce myself. I am Paul Meenan. I'm your host for today, and I'm joined by my regular tag team partners. Introduce yourself, chaps.
Hello, I'm JW.
And it's David here, aka Sparky Ninja.
And we are joined today by a plethora, which is a very big word, of guests. So can you all introduce yourself, who you are and who you work for?
I'm Sean Elliott Mayer. I'm a director at Earthing Services, overseeing operations and communications. And Earthing Services is the European partner enterprise of SAE.
My name is John Mayer. I am the technical partner of Earthing Services, also in the UK.
Hello, I'm Todd Sorolla. I'm the CEO of SAE, and we've been doing grounding engineering work and manufacturing a variety of grounding products for over 30 years.
I'm Rick Kennerly, independent contractor, subject matter expert for personal protective grounding in the electric utility space, both transmission, distribution, and substation.
Hi, I'm Chris Cox. I'm the utilities technical specialist for SAE. I have 35 years experience in the power utility network that before being recycled by Todd.
And I'm Rylan Boyd, the engineering manager at SAE, and I complete a lot of engineering design and field work for power utilities and gas utilities and everything in between.
Right. So before we go on, there's some words I probably should brief everybody listening to this. There are terms in this podcast that may sound a bit different from what we normally talk about, because this is the last in our series for now on the old earthing and bonding topic. But what we thought we'd do is we would push the boundaries outside of the UK, and we're going to be talking about a term called grounding. Now, to quote the definition of grounding from the Canadian wiring code, grounding is defined in the Canadian code as a permanent and continuous conductive path to the earth with sufficient ampacity to carry any fault current liable to be imposed upon it, and of a sufficiently low impedance to limit the voltage rise above the ground and to facilitate the operation of the protective devices in a circuit. So if you hear the term grounding,
Right.
makes it the same as earthing.
Right. When I write a book, I'm putting the word ampacity in my book.
Ampacity is an awesome word,
I like that
isn't
word.
it? It's probably going to end up in our wiring regs anyway. So we're not just talking about the big blue book. We're going to be talking about some of the codes in the Americas, and codes is another term for what we would call regulations.
Mm-hmm.
I think that's fair to say. Fair to say, chaps.
Yeah, no arguments here.
Okay, so we have over the last couple of months this year consistently talked about the differences between earthing or grounding and bonding, which is localized equalization of voltages within an installation to protect users under fault conditions. And we've talked about many challenges that it has for whether it be the domestic homeowner who are now being, we've got this mad rush for EV chargers, electric vehicles everywhere. Our government have just announced within 10 years that diesel and petrol are being phased out. So there's lots of challenges that comes with. We also have network conditions where the supply cables are ancient and failing, which is then giving rise to what we call broken protective earth neutral cables, which can then cause harm within the installation. And what it's doing is it's making the earthing or grounding and bonding a lot more complex within electrical installations. Now, what kind of challenges, that's just one of the challenges we have in the UK. What kind of challenges have you guys found where you are all based? Open to anyone.
Oh.
Well, I think we'll throw that straight over to SAE. Todd?
Oh, Chris, do you want to take this one?
Sure. Sure. It's where to start is the confusion there. There are a lot of challenges here. There's a huge focus over here as well on EV chargers and on grid modernization. With the changes in weather, the destruction of grids within certain utilities, the focus on rebuilding infrastructure has certainly brought the utility focus on to metal poles, corrosion, proper grounding, increased lightning, storms, fires. If any of you have been watching the news, you probably think California is on fire as we speak. So there's a lot of attention being put on grounding in North America, and Todd is in the middle of it.
So is grid integrity a big issue over there as well?
It is. As you can imagine, the sheer number of wind farms, solar farms, as you see a push towards EV over here, they are rushing to build massive solar generation facilities or offshore wind. And of course, connecting these to the grid and making it reliable in the face of the increasing number of lightning storms is a huge challenge. I could go on, but I don't want to take the whole hour.
Well, I also think it's worthwhile to point out that what we do tend to find on larger networks in the power utility sector, that perhaps where they were originally built to code, as time goes by, you have degradation of the systems, whether it's through corrosion or theft or other things like that, that all of a sudden, utilities are facing significant challenges with respect to their grounding because, quite frankly, it may not even be there anymore. So I think it's important to understand with respect to power utilities, for example, that the network reliability and the safety of the personnel can be tremendously improved by doing proper grounding. And it's also worth pointing out that there are strategies that you can use specific for lightning to improve the reliability of power networks. And I think that that's an area that there are severe challenges right now, because the strategy of using a 400-year-old tool to do all things grounding, which, by that I mean the ground rod, doesn't necessarily yield the most reliable performance under direct lightning attachment.
I think whether you're talking about earthing for whatever means, be it as the earth electrode for a lightning protection system, or for any sort of earthing provision, it's one of those things where the methods and the materials have changed so little for so long that the methods and the materials that we have are almost a base presumption, like gravity. Earthing equals earth rod, or the sorts of traditional and conventional ways that these things have been done. And when we think that earthing is ultimately a life-saving system, it makes deviation quite uncomfortable for people. Certainly, as there's a reputation that earthing is a bit of a dark art. So, if you think, well, I don't really understand it, and it always seems to have been done this way, so therefore that's the way to do it. Not to sound like Mr. Punch or anything, but it's there, isn't it?
It does seem that because it doesn't have much of an active impact on the end design from the engineer's perspective of, wow, this does work now, that they kind of don't change it. But when we look at over legacy and time, how we use electricity differently now, how we expose the systems to much more diverse currents, leakage currents, fault currents. This system clearly has to evolve with that.
Absolutely, yeah.
You know?
And if you don't mind me saying, so this is one of the things that we found on this little journey of podcasting is we did about 7 hours worth of podcasts on surge protection, and it immediately gravitated into lightning protection, which in the UK is BSEN 62305 suite of standards. And we had the now president of Atlas, which is the Steeplejacks Lightning Protection Organization. And he was sitting on our podcast going through educating us, where he was talking about with a lot of lightning protection systems, you have your standard down tape with your rods grounding the system. But in fairness, we're like buffoons, really, because we just bond everything, which can make the actual overall bonding and earthing or grounding of the installation actually more hazardous. Whereas if we select and erect, or what I keep saying on these podcasts, configure your earthing or grounding system correctly with your bonding system so that you are competently aware of leakage currents, fault currents, transients, network currents, lightning protection issues, we need to develop our understanding. Whereas you go onto any construction project of any size anywhere in the world, and they'll just say, well, we've got to make sure someone's doing the grounding or the earthing out, and let's stick some bonding conductors in, without realizing that if you don't size your bonding conductors, you can actually be you can have those bonding conductors carrying installation fault currents during normal operation, never mind fault. And that's the scary thing, and people only realize it when things start to go bang, or cables start to melt and fires occur, and then they get someone in who goes, wonder why that is. I mean, quick story, Dave knows this, John knows this. I'm currently investigating at the moment on my railway. I work on the railway, I'm the electrical manager there. I can go onto my LV earths, put an earth leakage clamp meter on an LV bond, and I'll pick up 30 amps.
Oh, wow.
30 amps, no problem at all. 30 amps, easily. I think it peaked at 59. 59, I think, if I remember right, Dave, was the maximum on an LV, low voltage, exposed green and yellow bonding conductor, not a grounding conductor, bonding conductor.
Yep.
Wow.
Which railway do I need to avoid?
So don't worry, it's still an equipotential zone. It's just got a lot of energy in it. That's all. It turns out we know what it is. It's the traction return from the overhead lines.
So connected straight into your system.
Rather than going into the track and down back to the transformer, our station is considered a low impedance at the grounding electrode, and it's then going into that. But it's taking all the fortuitous paths. So we have a lead water main, which is great. Nice low impedance piece of lead. Fantastic. So it wants to go down there rather than this big, thick, bulky rail with high impedance rusted joints, because somebody have maintained the track.
Yeah, I think the point about having a system, we like to refer to a lot of the work that we do as building electrical protection systems, and we do an awful lot of work in telecommunications. And your point is right on. Like you can't solve the problems that are presented unless the whole system is integrated. And you know, as an example, people talk about surge protection all the time. But I don't know how many telecom facilities I've been in where the you know, the grounding was not properly taken care of, and so the protective devices, even if we go back to plain old telephone, you know, the incoming lines, well, the surge protectors are fantastic, but only if they're grounded. And so you know, we actually do pay tremendous attention to integrating the system. We use layered surge protection, including the service pole, by the way, because your best chance to solve the problem starts at the service pole in many circumstances where the surge comes in from the power utility. And then we use layered surge protection on panels. And of course, if it's a telecom environment, if we stay with that example, we make sure that the line protection is also taken care of. But the source of all of the protection ultimately will depend on the low impedance grounding that you connect all of this stuff to. And it's, it's just sort of a recurring theme here. You get to a place that's had a problem, and then you have to audit it, figure out where the issues are. Sometimes the grounding is actually being rebuilt. We went to a switch years ago in Ottawa, and the switch grounding had been completely redone. Well, after 3 hours of crawling around under the raised floor, we realized that there were still loops internal to the building. So when lightning was delivered to the tower, it was conducted inside and blew up the switch again. But the contractor was happy to tell me, the contractor had done the upgrade, was happy to tell me the ground was below 2 ohms. And I just looked at him and said, well, how'd that work out for you? So the integration of these systems and actually having a system, if you will, for protecting critical equipment has to be very well thought out.
I was going to say, certainly in relation to the rails, you must have heard it. I mean, certainly in all of the rail projects I've been involved with, there's always this phrase that's thrown around, and it's earthing and bonding strategy.
Yes.
Earthing and bonding, what's the earthing and bonding strategy? And you just sort of think, well, usually there is just this complete absence of it. It's almost like safety blanket, or we'll say strategy, and then that makes us feel good, like we're actually doing something proactive and thought this through. And and the inverse is so usually the case. I'm just going to say this. I think John will probably remember this one better than I did, because he was the investigator from our company. I was just grabbing dust then. I wasn't, seeing ghosts. Yeah, John, there was a particular care facility that you visited that had an innovation with regards to lightning protection. Remember that one?
Right, this is where we had the all the electrical was blown up because of a lightning strike. And when we looked into what the problem was, it was the lightning wasn't bonded to the aerial supplying the whole of the facility wasn't bonded into the lightning protection system. So as a result, the lightning strike went inside the building, and then it just found blew up the telecoms, the TV system, and then took out the power supply as well. So although it had light protection, it just wasn't bonded into the aerial.
Oh dear.
So, and it happened a couple of times before we were called in. But we have two sides to our system. One where we actually design electrical earth systems, and we look at everything right from the ground upwards. First off, let's look at what we're dealing with. What are the actual faults we're having to contain within the earth system? And from that, we then build up, looking at line protection, all the internal bonding, surge protection. So before we can leave the drawing board, we have to ensure that site is safe. And then it's just down to, it's handed over to the installation guys then. From the other side of the business, we will investigate problems. You tell us what your problem is, and we'll provide a solution. But unfortunately, that process can take some considerable time. We were working with a major telephone organisation within the UK. Surely you'll bear me out on this one. It was 18 months before we actually got down to the nuts and bolts of what the real issues were.
Yeah, what's trying to be achieved? That's the big one. What do you actually want to achieve from this? Because, it's one of those things that when it comes to earthing or grounding, light protection, electrical safety, we're good at that. Mind reading, not so good.
The trouble is, if you don't mind me saying, is are we any good at it? Because I'm finding as time goes on that the comment you mentioned earlier on about an earthing and bonding strategy, I have sat in many meetings for many new builds of railway stations where a designer will go, oh yes, and our deliverables are the earthing and bonding strategy, the civils designs, the architectural design, oh, and by the way, the EMC strategy. And I sit there and go, but is an earthing and bonding part of EMC? So would it not make sense for them to go as one? Because if you're considering the EMC, EMI, EMF, and earthing and they're kind of shielding. It's all part and parcel. And have you read this standard? And you can see in the whites of their eyes them going.
Well, it's the
yeah.
same.
And
when we
you
do,
almost hear them subconsciously going,
yeah.
I'm cutting and pasting the last one that we followed somebody else did.
If you remember the surge protection webinars that we did when we moved on to lightning protection, one of the things that he was always saying is lightning is always considered as an afterthought. If there's any money left, but it should be done right at the beginning, combined with your earthing strategy, if you want to, But a lot of the times he finds that in the UK specifically, lightning protection is considered as is there any money left in the purse for this? Right at the end.
Yes,
But by that time, you've actually lost the opportunity of using natural conductors.
Yep.
It's the same globally, if you don't mind me saying. It's whatever money's left after the concrete farmers and the hole diggers have had their fun and made their mistakes. And I've always said that the poor cousins are always lightning protection and emergency lighting. They seem to be the ones that are de-scoped and value engineered to the point of a sandwich box with a bulb in it on the ceiling and maybe a bit of wire around the building if you're lucky. But just on that, because it's fairly evident that we have globally the same problems, regardless. One thing I didn't reference to, obviously you guys use the term grounding, we use the term earthing, but we have the same term bonding. Now, I'm going to read out for those listening and watching, bonding under the Canadian code, which I love, is defined as a low impedance path obtained by permanently joining all non-current carrying metal parts to ensure electrical continuity and having the capacity to conduct safely any current likely to be imposed upon it. Our regulations, potential bonding is an electrical connection maintaining various exposed conductive parts and extraneous conductive parts at substantially the same potential. I know which one I prefer, and it's not this blue book. There's better English in the Canadian code, to be perfectly frank, although grounding is a totally new term. But when you think about what grounding is, it's the exact same as earthing. It's just a different way of spelling it out. Right. Okay. So we have global challenges. I think it's fair to say that money, competency, strategies, configuration, all of them are keys to getting the right earthing and bonding system. But if we take this down to another level, which is the domestic setting now, John, you're still on the tools doing. John Moore, do you do any EV charging or drive any electrodes as part of your day-to-day work?
Not yet. It's something we were doing next year, hopefully. So
Okay.
Not currently, but the whole domestic thing, or the sort of residential thing, as you call it, probably over there, is that most like houses or similar here do not have their own separate earth electrodes or anything else. They're purely relying on the cable that's coming in from the electricity supplier. So this whole concept of putting in earth rods at certainly to people's dwellings is pretty much never done. It is in the regulations to actually do it, but of course it's optional. And of course, if things are optional, nobody actually bothers. They say, oh, we don't bother with that, it's optional. So, and now, and certainly the regulations we have over electric vehicle supply equipment is, it certainly was the case that people were actually going around and just banging in earth rods here, there and all over the place because it said in the book, oh, you must do this or do that, with no real knowledge or intent of what they were doing. And of course, there's just ramming these rods into the ground right next to the supply cable and piercing through gas lines and all the other kind of trouble that goes with it. So in sort of that particular sector, the whole concept of putting in earth rods for your electric station is pretty much unheard of, as it's really never been done.
Yeah, I think that's fair to say. Well, the reason that was a leading question, John, is I am a big fan of innovation. I am also a big fan of doing things differently, because I've always said this, sometimes the way we always do things isn't always necessarily the right way of doing things. It's just the bad behaviors and poor competency that we've inherited, possibly. And one thing that the reason I asked Earthing Services and the chaps from SAE to come on is these guys have some products. And by the way, before anyone says we're not sponsored, there's no money exchanging hands. We're just 9 saddos talking about earthing and bonding together across the planet. Okay. But the one thing I will say is I'm just going to highlight this one thing in my hand here, and it's a data sheet for something called a condudisk. Now, I saw this and it's got me very, very excited. So does one of you chaps want to introduce us to what a condudisk is? Because it's basically earthing without rods.
Right, I think that one's for Todd. Well, do you want me to start with it?
Go for it.
You could go ahead, John.
All right. Well, Todd sent over one of his latest devices, of which there are quite a few in the pipeline still to be exploited. And I thought, I cannot see a use for that in the UK. This condudisk, it's going to sit underneath a timber utility pole. But we had a problem to solve for one of our major clients, where there was a block of flats in Manchester where they were dependent on the neutral from the PME, as you know, if a fault occurred, to deal with it. But there was a fault in the neutral which wasn't picked up, and it became evident that we had to do something about, providing a TT earth. So the quick fix was using Condacrete. But subsequent to that, we thought, what is a conduit? It's basically an electrode. It's a means of dealing with a fault to earth. So from that, we thought, why not? There's no need to drive earth rod electrodes for electric car charging points when the regulations changed in 2018. And subsequent to that, they've become very, very popular. All that's required is to use the existing excavation for the charge point and just sit this disc underneath it. So there's no additional work. The cable's already made off inside the disc itself, so there's no terminating. All that's required is to literally connect it to the to earth terminal within the charging point. As simple as that.
Am I correct in saying that you are going to position a charging point, maybe in an industrial site? You're going to do the civvy work first, dig the hole to put the concrete in, to then put the charging point on. You're saying that we could just place the condudisk underneath that foundation material?
Absolutely.
Okay.
Yeah, I mean, just for the benefit of anyone listening who may not have seen Paul's wonderful modelling of the data sheet, Todd, do you want to actually describe, well, again, wow, this is just a whole new career that's going to open up.
So I guess the simplest way to describe it, it's a disc. We put a conductive polymer to surround a galvanized steel plate that's inside it so that it won't corrode, which is, one of the main issues with any direct buried metal electrode is how long is it going to last?
Yes.
But then we also paid attention to the size. It's equivalent to a 3-meter ground rod in its surface area. So instead of going to a site and having to drive the rod and perhaps hitting something, or in this side of the pond, we have a lot of people that are driving them manually and they get hurt. So when you consider the safety improvement and the labor savings and the performance, being equivalent, and sometimes it's even better than a driven rod, it starts to look, like a pretty good idea. And I think it's important to understand that doing things differently sometimes means that you're doing them better. And the tendency in the industry is to kind of put something that's different aside and decide that you're going to use it perhaps 20 years from now. And that really is an issue when you innovate.
Yeah.
in this
Can I pick up
environment.
on that one, Todd?
Sure, go ahead.
I mean, there's a phrase that we often use, which is, if lads weren't smarter than their dads, we'd all still be living in caves. But the truth of the matter is that, you know, at some point, someone had to step out of the cave.
Yeah.
And stepping out of that cave and doing things a little bit differently, that must have been a scary moment. And in the same way, if you look at the evolution of electrical earthing, we start with Benjamin Franklin with a kite, with, you know, a little bit of copper hanging off the end going into the ground. And there we get our first experiments with lightning, and we understand that. Then we get Michael Faraday with, you know, the grid, the cage, that we then came to rely on. The next innovation, you know, fast forward, what, 160, 70 years, about more. And then you get to sort of a couple of accidental innovations where, you know, they kind of the happenstance of, oh, that seems to do this, maybe it will work for that. Great. But in terms of sitting down to say, right, let's develop something new, let's do this better than the earth rod. Let's do this better than having to just keep pouring copper all over everything. And that more or less comes up to SAE starting with Condocrete, you know, one of the other products, which we can talk about in a little bit. But then, again, I'm not an anthropologist, but as I understand it, one of the differences that sort of differentiates a human being from not just the other primates, but, you know, all of animals, is that we don't like to solve a problem. We like to solve a problem again and again and again and again and again. So we don't just need to get a tool that will do this and we can just sort of jam it in. No, we'll get something more precise. And actually, in different circumstances, we'll do something in a different way, and we'll keep solving these same problems. But again, we get something like electrical earthing, and we get to rods and tape, and then it's done for a long time. Along come the guys at SAE who say, well, actually, no, we'll solve that problem. And oh, look, well, actually, instead of just trying to adapt that same solution to this, then actually we could do something different for that. Okay, we'll develop a new product. Oh, what about that problem over there? Oh, well, actually, instead of adapting this, we can just do a whole new product that will solve the problem better. And it's that philosophy of, we'll do some heavy lifting our side to develop the best product that will be, you know, usually specific to that application or directly translatable, as we get with something like the Conjure Disc. And then, okay, right, there's a different problem. We'll go and get something ready for that. You know, we're dealing with rock. Okay, these solutions won't work for that. We'll go and figure out something for that.
So this, if you don't mind me saying, this is what blows me away, because when I first found out about the earthing services and SAE, and please, I'll put the link in the YouTube description below, but please check them out, because for me, one of the biggest struggles that electricians are having in the UK at the moment, if they are working, even if it's industrial commercial, if you're doing lightning protection, you've got the ball ache of, I've just put lightning protection rods in at Fenchurch Street, which was a nightmare. Because you can imagine outside Fenchurch Street, in the middle of densest London, you have gas mains, utilities, fibres, everything everywhere. It took us a lot of time and a lot of digging up of the street to find a place where we could put an earth electrode, because the last one had disappeared, literally just turned to dust. So again, that's from doing proper maintenance. But what blew me away is the fact that I can dig a hole, as it's, tell me if I'm wrong, about 600-700 mil deep. Which isn't that much, not beyond the realms of impossibility for a spark who's digging out an earthing access cover, drop this thing in, and voila, I don't need to do any hazardous scanning. I don't have to put an earth electrode 2 meters down, plus another one, plus another one. I can just drop this bad boy in. If I want to increase the likelihood of it giving me a low impedance, use some Condocrete, which is we'll get onto in a bit. And then that's it. I've got my local earthing. So whether I'm doing EV charging, lightning protection, this is a new way of doing rodless earthing.
Yeah. See, for me, if I think about when we did our lightning protection webinars, podcasts, one of the things that was quite clear is Europe is ahead of the UK. And over there, they won't use copper. you know, steel, galv. And over there, if you say copper, they will probably just pick up an electrode and hit you with it. They just no. So when you think about the way that they're changing or they're moving forward there and leaving copper, you know, not even touching copper over there, combining that with the fact that, as you say, but with Fenchurch Street, where your copper electrode was just basically chewed away by the currents. Hearing that, so this is a steel disc. What's it coated in?
It's a conductive polymer. It's a proprietary material that's conductive, but also very low permeability to water. So what happens when you do that is that the life expectancy goes up by about a factor of 20 over what it would be as a bare metal.
Which is brilliant for your life cycle expectation. Which we discussed in our asset management discussion.
Well, it says on the data sheet it can last up to 60 years. Obviously, that's dependent on ground conditions, external influence.
Right.
Yeah.
But that, from an asset management perspective, is amazing. I put an earth electrode in again, I'll use an example. Stratford Railway Station. We were building some new London Underground platforms, and there are 2 HV traction systems, and there are 2 DC traction system, a third rail and a fourth rail. And we put some rods in for the site temporaries, came back just over 2 years later. They were gone. The only thing that was there was the connection on the top of the rod. Everything in the ground had just disappeared.
Yeah, so this is a very important point you're making, because what we've discovered is the same thing as you. And in these DC environments where you have a lot of stray DC moving, I mean, when we do accelerated corrosion testing in the lab, that's how we do it. So you have to understand that, especially in many urban environments where you have so much buried infrastructure and you have a lot of DC, whether it's from rail or it happens to be cathodic protection, what have you, the metal that you put in there is not going to last near as long as you expect. And in cases that you're describing, 2 years is aggressive, but it's not unusual. So that's why when we talk about any of the materials that you'll hear about on these discussions, if we go back to the disc, for example, there is always going to be a conductive matrix around that metal, the electrode, that is low permeability to water. The other thing you have to understand is that these materials are carbonaceous. Our favorite color happens to be black. You may have noticed that. So that means that when DC is migrating around, moving from point to point to get back to source, the carbon will be consumed in that transaction, not the metal that the carbon surrounds. Okay, so this is a very, very big deal, and it's something that very few people understand, and that's why we're taking pains to make sure all of our solutions address that problem and stop the corrosion of the metal.
So let me interject in the conversation here. Y'all brought up some very good points concerning asset protection, management of your assets to live a long life, to prevent corrosion and those type of things. But let's also think about the workers, the electricians that have to do planned maintenance on these systems. They're relying on these electrodes for personal protection, whether it be from capacitive induced voltages or magnetic induction. They assume that these protective devices are working or in place. The issue there right now is they may not be, based on the conversations we're having about couple years, 3-4 years later, these electrodes are turning to dust. So I guess my message is to bring out to the electrician, to the workers that are listening to this, to be cautious of you're working right now. You have to assume that these electrodes are not in place. So from a barrier standpoint, I would suggest, wearing your boots, your dielectric boots, wearing your rubber gloves, protecting yourself from a personal protective standpoint, because there are such things as touch voltages, step voltages involved during faults, and then day-to-day operations, depending on your environment. Capacitive induction can be lethal, as well as getting in series with magnetic induction.
Yeah, absolutely. That's a really important point You know, these systems are supposed to be, you know, they're life-saving systems. When they're needed, they need to work. So if the components that they, you know, of which they're comprised are no longer there or insufficient, you know, if it's, you know, deteriorated to an extent where they're no longer able to carry the fault, then that's going to come back at the poor guys who've got to do the installation. And again, I'm not even going to mention sectors on this because I think that's the safest thing for everyone. But you know, there are certain perspectives where people who make decisions relating, certainly when it comes to maintenance of large-scale systems, particularly when it gets down to earthing, you know, you've got to remember these things are being buried in the ground, and if something's in the ground, it's hard to check if it's there. And if it's hard to check if it's there and it's buried in the ground, so you can't really see it whether it's there or not, it's very easy to forget about and actually overlook. Oh, yeah. And then presume, well, it can't be a problem. It's not likely to be a problem. You know, well, I don't even want to look at the budget as far as that's concerned. It'll be fine. Well, those decisions are okay to make if you're in an office and you're never going to go to site. But if you're the guy who's actually got to go, either whether it to be to drive a rod or to do some work on that system, nothing to do with that. You know, it's just a case of, all right, we'll just connect onto that so that we've got that protection of the earth. Well, if the earth isn't there or it's not functional, then that's their lives on the line, not the people, you know, sometimes a long way away making those decisions.
Just to follow on from that, and it's a really valid point, because one of the things that I've mandated on my guys, Dave knows this, is that all my electricians now have to carry earth leakage clamp meters. And before they do any work, I'm asking them now to check the earthing system to make sure there's no potentials on it. I'm asking them to check it for any leakage currents, any current at all. There's no unauthorized disconnection of any earth, period. If there's a connection of a new earthing system, it's got to be done at night when the entire railway is shut off completely, because I don't want any arc flash hazards occurring. So yeah, we need to, I think for electricians, sadly, and I don't know how this is in the Americas, but we need to think and consider the earthing and bonding systems just as potentially hazardous as a line conductor.
Well, there are areas that we're not as aware of that they are over there. I mean, you mentioned arc flash over there. You've got NFPA 70E and all those approaches. Doesn't exist over here. We rely heavily on working practices to just assess risk and don't do the work, but some work has to be done. And especially if we're assuming that the presence of an adequate earthing system will prevent, if the adequate earthing system is not maintained and if it's chewed up and it's dust now, the work's got to be done. And if there's a risk of arc flash, we've got to obviously identify the risk and prevent that, such as the insulated boots, such as the category equipment, such as the suitable working procedures. A lot of people still think a buried electrode is safe because it's buried and it's not going to be, you know, it's not going to cause any harm, but they don't really understand the currents that are actually being subjected to that electrode, obviously under fault-free conditions by just the natural characteristics of your system, and under fault conditions. They just don't understand it.
Well, I have to say that Stratford is probably the worst place to be working. We have three systems there. We have the Docklands Railway, we have the London Underground, and we've got HS1 passing underneath, where there's 3 substations which I actually designed for the HS1 that pass straight around there. So, you know, from 25,000 volts AC, 750 volts DC, all in one area.
I also happen to know that there is no earthing and bonding strategy for Stratford as a holistic area. I know because I asked for it and I got a load of blank faces. But just on that, and trust me, I did get a load of blank faces in 2002. Just on that though, again, going back to the safety of the worker, very important. One thing that a lot of electricians are finding, and probably too many now, because when I was younger and I was testing on the tools, I knew that I could go out and do a ZE, an earth loop impedance measurement on my network supply, and generally you knew the values, you knew what the regulations or the code had as a maximum, but you were well under because it was a very good low impedance network. Fast forward 20 odd years and the numbers are creeping up and up and up past the values that are in the code or the regulations. But then when you go to network operator, they then go, well, it's still okay, and they allow you a little bit more, which
Just push the maximum up with it, haven't they?
yeah, they've raised the maximum bit, and straight away you go, there is a problem on the network. Now, what's happening is a lot of electricians, especially the commercial industrial electricians, are going into buildings where there may be large warehouses where that external supplier is gone. It's corroded, it's disappeared. It has done for years, but the earthing is managed by the bonds connecting to the structure, henceforth grounding it sufficiently. And only when there's a major shutdown or a change of ownership and a refurb that they find they don't actually have a designated grounding or earthing conductor which will take faults back to the transformer. And we're finding that more and more and more in this country. It just shows you nobody's properly looking after and maintaining these systems, which, given they're for safety, it's quite a worry.
Yeah, overlooked and undervalued because they're underground.
Yeah, indeed. I think on that, gents, we're going to end this one, but we're going to ask you back, because otherwise we'll end up going into the 10-hour marathon sessions. So if it's okay with you, we'll by the magic of the internet, we'll end here and we'll come back in a week's time, or maybe 5 minutes. So does anybody have...
Do I have to change my shirt?
Hold it. I've got Stratford down, and where else do I have to avoid?
East of London.
East.
Yeah, East of London and most of North London. Just London in general, really. Yeah, chaps, thank you very much for joining us. Do anyone have any final thoughts they want to put on this episode? Any final comments?
If this is obviously the one you're listening to, and you're not going to listen to the next one where we're going to talk more about this conjugate, look it up, and also bear in mind that it is a much safer method of installation from a safe working perspective. No driving of electrodes. For me, who does training, that's a huge benefit, as well as the electrical benefit, not having to drive electrodes. We haven't mentioned the too much about the increased level of safety that's actually achieved with not having to drive an electrode. So I just wanted to throw that in just to close this one off for me.
Anything else?
Oh, that is a good point. As he said below there, often we are contacted after an accident, right?
Yeah.
There's accident. If you can prevent the accident, then that's the place we should be.
I think that's as good a place to end as any.
Right. That's it then. Until the next one, thank you. You know the usual spiel, everybody. Thank you to my tag team partners. Thank you to Earthing Services in the chat from SAE. And until the next one, take care of yourself and each other. Bye-bye.